Alright guys, welcome to this page of the notes, and here's what we're going to do. We're going to take a look at the discriminant of the quadratic formula and use the discriminant to help us figure out what kinds of solutions the quadratic formula is going to give us. It's just this simple. The discriminant is what's in red, the b squared minus 4ac. So that's all we're going to do. We're just going to pull out that b squared minus 4ac. That's all we're going to calculate. What this is you are not actually going to be finding solutions. You're just simply going to be telling me, if I were to solve the quadratic formula, here's the kinds of solutions I would get. Let me show you how this is going to work. There's only three possibilities. You could solve, or you could plug in b squared minus 4ac, and you could get 0. Well, if you get 0, the parabola lies, the vertex lies on the x-axis, and you get one solution. I'll show you that in a chart here in just a second. The second possibility is you do b squared minus 4ac, and you get a positive number. Doesn't matter what the number is, it just comes out to be positive. All right, well, this could go one of two ways. If it's a positive number and a perfect square, you're going to get two rational solutions. If it comes out to be a positive number, not a perfect square, you're still going to get two solutions, but they're going to be irrational. So that's two options. It comes out the discriminant is 0 or the discriminant is positive. And third and final option, you do b squared minus 4ac, and that whole thing comes out to be negative. In which case you're going to wind up with two imaginary solutions. Right? So let me show you how this is going to work. Right here. This is what we got. You are going to calculate b squared minus 4ac, and the first option is you get a positive number, right? So you plug in b squared minus 4ac, you get a I don't care what the number is, but it comes out to be positive. Now, if that positive number is a perfect square, you're going to get two real rational roots. They're going to be rational numbers, and you'll get two of them. If you do b squared minus 4ac, and it comes out to be a positive number, but that positive number is not a perfect square, you're still going to have two solutions. They're still going to be real, but they're going to be irrational. They're going to be irrational numbers. Other option, you do b squared minus 4ac, and it comes out to be 0, in which case you will only get one real solution. And the very last option, b squared minus 4ac, is going to be less than 0. That means it's a negative number. Well, if b squared minus 4ac is a negative number, that means you're taking the square root of a negative number, and we know that means complex. It's imaginary. You're going to get two imaginary solutions. So here we go. Let's go ahead and try a couple of these and see exactly how they're going to work and what it is I am asking you for. Remember, you are not actually solving the problem. You're just telling me, here's what I would get if I did solve this quadratic. So here's a quadratic for you. And let's go ahead and find the value of the discriminant and then describe the number and types of solutions. Okay, well, I got ax squared plus bx plus c is equal to 0, and my discriminant is b squared minus 4ac. So let's go ahead and do that. B is a negative 11 minus 4. My a is a 7. My c is a 5. All right. Negative 11 squared is going to be 121. Negative 4 times 7 times 5 is going to be a negative 140. 121 minus 140 is going to be a minus 19, and that's all I need to know. My answer, b squared minus 4ac, comes out to be negative, which means b squared minus 4ac is a negative number. You're going to have two complex solutions. So the answer is two complex solutions or two imaginary numbers. It's just that simple. Let's try another one. Okay. I need to find b squared minus 4ac, so let's go ahead and do that. My b is a 22, so I'll have 22 squared minus 4 times a, which is a 1, times c, which is a 121. All right, 22 squared turns out to be 484, and a negative 4 times 121 is also 484, which means I get 0. Well, hopefully you remember from the chart, if b squared minus 4ac comes out to be 0, you will have one real rational solution. One real rational root. That's it. That's all you got to do. Let's do another one. Okay. Let's see here. I need to do b squared minus 4ac. Okay, we can do that. My b is going to be an 8. So it's going to be an 8 squared minus 4 times a, which is a minus 5, times c, which is a negative 1. 8 squared, of course, is 64. Negative 4 times the negative 5 times the negative 1 is a minus 20, which means that I wind up with 44. Okay, 44 is a positive number, but 44 is not a perfect square. Not a perfect square. So positive number, not a perfect square. So when I take the square root of 44, it's going to be irrational. So I wind up with two real irrational roots. And again, that all just comes from the chart. But it should make perfect sense, right? The b squared minus 4ac, you're going to take the square root of that, and the square root of 44 is irrational. So you don't even need the chart. You know they're going to be irrational numbers. Let's try another one. And this one. So I got to do the discriminant, which is going to be a b squared minus 4ac. My b is a negative 7, so negative 7, which I will square, minus 4 times a, which is 15, times c, which is a negative 4. All right, well, negative 7 squared is 49. And a negative 4 times 15 times a negative 4 is a positive 240, so plus 240. All right, so I got 49 plus 240, which would be 289. Believe it or not, 289 is actually a perfect square. In fact, let me grab my calculator and show you. If you take the square root on second square root of 289, it is 17. So the square root of 289 is equal to 17. Well, here's what that means. If I take the square root of 289, it's a perfect square. That means I'm going to get two real rational solutions. Two real rational roots. And it's just that simple. Guys, that takes care of this set of videos and these notes. Guys, I hope you had a really good time, and at this point you should be comfortable using the quadratic formula as well as finding the value of the discriminant, not to solve the quadratic, but just to simply let me know, hey, if I were to solve it, these are the kinds of solutions I should get. Thanks so much for joining me for this set of videos, and I'll see you guys next time.